Hello, Firoz. Am I audible? So no one joined till now. Okay. So am I audible? Please just confirm. Hriday, am audible? If yes, let us please solve the first question. Okay. So now let us start. So the first question is, Pascal law state that the pressure at a point is equal in all directions. This condition is applicable for first option, laminar flow; second one, fluid at rest; third one, liquid at rest; and option D, turbulent flow. So which option will be correct? Please just try to write your answer in the chat box. Okay, so Patil is telling option B is correct. The fluid at rest. Yeah, definitely. The Pascal law or talk about when the fluid is at rest. So your option is correct. This is a very basic question from your fluid statics. So now let us go with the second question. Question second is, let me just go in the second question. So how the explanation is according to Pascal law, at any point in a static fluid, the pressure is the same in all direction and hence the pressure is scalar quantity, and this is applicable for liquid as well as for gas. So it should be for a fluid at rest. Option B is correct. So now let us go for question number 2. Very interesting, very important. So Archimedes principle is and are maybe one or more than one option correct. So A, the floating body displays its own weight in the fluid in which it flow. The option B is there, and option C and option D. So please just try to write your answer in the chat box. Just read the question very carefully. Okay, so Rajkumar is telling D option. Other participants also just try to write your answer in the chat box. I'm waiting for another response, please. Just try to write your answer. You have 1 minute more. Okay, so now let us explain. So yes, option D is correct. So as per Archimedes, so what option A and B both are correct. A floating body displays its own weight in the fluid in which it floats. The meaning, when let us suppose you have put a body which is floating in the fluid, and whatever the volume is within the fluid, that much volume or that much weight of the water will be displaced. So and this will be equal to your the weight of fluid, the weight of your displaced fluid is equal to weight of the body. So the first one is correct. Option B, a body immersed in a fluid experience of vertical buoyant force equal to the weight of the fluid displaced. This is correct. So both option is correct. So now let us move on the next one. Here explanation is given very well, so you can go through. Now numerical 1 marks. So Umiam Lake is a freshwater lake near Ceylon. India has a maximum depth of 40 meters and the mean atmospheric pressure is 91 kilopascal. Estimate the absolute pressure in kilopascal at this maximum depth. Take the specific weight of the water 9709 Newton per meter cube. So you have to calculate. Please, you have 4 options. So estimate total absolute pressure in kilopascal. So I'm waiting. Please just write your answer in the chat box. Okay, Rajkumar is telling option C. So other participant also just try to write your answer in the chat box. You have another 2 minutes. Okay, so this is very simple question. Let me just show you the answer. Here you can see the pressure is nothing but P is equal to rho H. Your density in the question it is given. In the question a specific weight is given. A specific weight is nothing but this is rho and G. This is a specific weight and 40 is the your depth. In the question it is written itself 40 meter. So now the rho Z is 9790. So you will get this Pascal. Now the question is asking about that absolute pressure. So this is your gas pressure. Now when you will add the atmospheric pressure you will get the absolute pressure, and atmospheric pressure is nothing but it is your 91 kilopascal. So finally we get 482.6 kilopascal. So option C will be correct for question number 3. Now let us move for the next question. Question number 4. A manometer is used to measure the pressure in a tank. The fluid used has a specific gravity of 0.85 and the manometer column height is 35 centimeter. If the local atmospheric pressure is 96 kilopascal, determine the absolute pressure P within the tank in kilopascal. So you have option A, option B, option C and option D. So please just write your answer in the chat box.
Yes, what time? No, 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 no. If you will see, how this time I know you have something like that, then I can like this. Yes, yes. So 2 hours, 2 hours. I'm attending the class. So 2 hours. How is that? Okay. Then pop. Pop. This. This is this. This is this. Oh, this is. Yeah. Yes. No. Yes. How? Five. Five. 5 minutes. I will live more.
So Ranjit is telling option D is correct. Okay. So other participant also just try to write your answer in the chat box. So I'll give you 1 minute more, please. So within 1 minute, just try to write your answer, please.
People of Taiwan. It's Taipei. Travel. I travel. What?
So okay, let me just explain you. So the question is asking about the what will be the absolute pressure. Again the similar question. Absolute pressure is nothing but your gauge pressure plus atmospheric pressure. So you have to calculate first gauge pressure, which is your rho gh. In the question you have the specific gravity. So how you will calculate the density? Density is nothing but your specific gravity into standard fluid density, which is 1000 for water. So this is 0.85 and 1000, this will be rho, and g is 9.81 and h is given 35 centimeters, so you have to put in 0.35 in meter. So finally we will get 2.918, and atmospheric pressure in the question is given 96, so finally we will get 98.918 kilopascal. So here your option B is correct for question number 4. So now let us move on the next question, which is very interesting one. So a tank contains two immiscible liquid of densities rho 1 and rho 2. So rho 2 is greater than rho 1, that is rho 2 is heavier than rho 1. If the height of the column of the liquid which has density rho 1 is h1 and that of the liquid with density rho 2 is h2, so the pressure at the interface between the two liquid is, so option A, B, C, D is given. So just think, very interesting question. So try to solve this question please and write your answer in the chat box.
Sir, I'm having doubting previous question also.
So what is your doubt please?
Uh, Sir, it is rho g into h, sir.
So here you can see this is for the previous question is rho gh. So yes, so rho in the question specific gravity is given 0.85. So specific gravity is what? The specific gravity is the ratio of your density of your the fluid divided by the standard fluid. So when we will calculate the density, so specific gravity and a standard fluid your density. So this will give you rho, and then g is there, and h in the question is given. So this is you will get in the Pascal, so you have to convert in the kilopascal. So finally this is your answer. Now for question number 5, so you please just write your answer in the chat box. Hope you understand the previous question. So let me just explain you question number 5. So here, yes, this is definitely rho 1 g1 h1, because the question is talking about you have like that. The heavier one will be the below rho 2, this is your rho 1, and the height is h1, here height is h2. So your pressure will be at this location from the top. This is your liquid, so it will be at this interface. So rho 1 g h1. If question was asking at this location, so you have to combine all. So but question is asking here, so your rho 1 g1 h1, so option A will be correct. Hope you understand. So now let us move on the next one. Yeah, option A is correct. Thank you. So now the next question, question number 6. For a floating body, the metacentric height is the distance between. So you have 4 options. So please just try to write your answer in the chat box. Okay, so Ranjit is telling option A, that is center of buoyancy and center of gravity. Okay, so question is, for a floating body, the metacentric height is the distance between. So you are telling the center of buoyancy and center of gravity. Okay. Other participant also just try to write your answer if you have idea. Okay, so let me just show you the answer. So actually the metacentric height is the distance between center of gravity and metacenter. So remember always please. So here explanation is given. You can go through. So metacentric height Gm is the distance between center of gravity and the metacenter M. It indicates the stability of the floating body. So now let us move on the next question. Question number 7. Yeah. So which of the following statement is true for a fluid at rest? And there are shear force present in the fluid. The fluid velocity varies linearly with depth. The fluid pressure varies linearly with depth. And there are no shear force present in the fluid. So which option will be correct? Okay, so Rajkumar is telling option D. So I'm waiting for other participants.
Option D or
Okay. Okay, Srisankar. So Ashok is also telling D. So D should be correct. Let me just go. Yeah, option D is correct for question number 7. So the explanation is, in a fluid at rest, there are no shear force because shear force arises from the fluid motion. The only force present in the static fluid is the normal force due to pressure. Now let us move on to the next one. Question number 8. So the concept which defines the pressure at a certain horizontal level in a static fluid is proportional to the vertical distance to the surface of the fluid is known as Pascal law, the Magnus effect, Archimedes principle, or hydrostatic paradox. So which option will be correct, please? Okay, so Rajkumar is telling D and Ashok is telling B. Okay, let me just see. So let me just show you the answer. So it is hydrostatic paradox. Remember, please, option D will be correct. So what is the solution? The hydrostatic paradox states that the pressure at a certain horizontal level in the fluid is static. In a static fluid is proportional to the vertical distance to the surface of the fluid. That means on horizontal plane. At each point, the pressure is same, provided by the interconnected by the same fluid only. So remember. So next one, question number 9. So a cube of dimension 2 meter is floating in the water with a merging depth of 1 meter. The unit weight of water is 10 kilonewton per meter cube. So what is the weight of cube in kilonewton? Okay, so he's telling option A. Okay. Okay, so let me just show you the answer. Yes, A is correct. How? A cube of dimension of 2 meter is floating in a water within an immense depth of 1 meter. Means you have, let us suppose, one cube which have the depth of 2 meter. Okay, so 1 meter in mass. This much within water. This is 1 meter. The unit weight of water is 10 kilonewton. What is the weight of the cube? So weight of the cube is what? As per the Archimedes principle, the buoyant force is equal to weight of the body. So what will be the buoyant force FB? FB is nothing but the weight of the displaced volume, weight of the displaced water. So rho G and volume. What is force? Force is nothing but your mass M. So what is M? M is rho by V. So what is your, no sorry, rho is equal to mv. So what will be the m? M is rho into v. So this is rho into v and g. And weight of the cube, weight of the cube is what? So the unit, here it is given the unit weight 10 kilonewton per meter cube. So you have to multiply with the volume. So volume of the cube is 2 into 2 into 1. So finally you will get 40 after the calculation. So your option A is correct for question number 9. So the here it is a immersed volume. Remember please, this is your y1 because we are considering the immersed volume. Because why immersed volume? Because the immersed portion only displacing the water, not all portion of the body. That's why. So now let us move on the next question. The specific gravity of an oil is 0.8. What will be the equivalent head of oil if the head of water is 400 centimeter? So please just try to write your answer in the chat box. I am waiting. Okay, so is telling option B. Other participant, please just write your answer. Okay, so let me just explain you. So you have the specific gravity of oil is 0.8. So the density will be 800 kg per meter cube. If the head of water is 400 centimeter, means head of water means what? H you have 400 centimeter means 4 meter. So this is so one thing is important, what the both side pressure of due to oil is equal to the pressure of water, because question is asking what if the head of the equivalent head means the pressure equating. So pressure is what? Rho gh. So rho is 800 into gg will be cancelled out, and h of the y is equal to, so here also rho of water g and h. So g and g will be cancelled out. So here your, and why this is written like that, as you know, how we will get the 800? So rho of oil divided by rho of water is your specific gravity. So rho of oil is nothing but specific gravity into water, rho of water. So it is written here. Rho of water will be cancelled out. So it's the gravity of oil and height and equal to the height of water. So finally you will get the 5 meter. So option B will be correct for question 1. So now let us move on to the next one. Very interesting. A block of concrete weight 500 Newton in the air and weighed only 250 Newton when immersed in the fresh water. Specific gravity, the specific weight is given here. What is the average specific weight of the block? So you have four options in kilonewton per meter cube. So actually today I have the power problem, the electricity. So after 1 hour, maybe after 5 minutes, I'll join through my mobile and then I'll record the session and we'll discuss the questions. So in between, if the call will disconnect, so please be there. I will join.
Okay, sir.
So let me just show you the answer. So here you have the concrete weight 500 Newton. When we immersing in the water, the weight is only 250 Newton, as you know, due to the buoyant force. So the question is asking about the average specific weight of the block. Now, now let me just show you the solution. So concrete weight is nothing but the rho, the gamma into volume. So which is in the question is given 500 Newton. The air effect neglected. When we immerse in the water, so you have to take as a saturated weight. So gamma of the block minus your unit weight of the water into volume. So this is equal to 250. So you have two equations. One when you are immersing in the water, another when in the air. The average specific weight of the block you have to calculate. So when you will go for calculation, you have the just divide the things, the equation 1 and equation 2. So after the calculation you will get, and row of water in the question is given. So 9810. So once here you will put 9810 in the Newton per meter cube, but here you need to put in the kilonewton. So it will be 9.81. So finally you will get 19.62 kilonewton per meter cube. So hope you understand the question number 11. Now just question number 12.
So on 4 August we have solved the 12 question for week number 2. So due to electricity problem, there was a electricity problem that time, so we have solved up to the question number 12 only. So let us start with the further. So that time I have recorded only 1 hour, so remaining 1 hour I am going to record here. So we'll see a lot of questions. So we have solved up to question number 11, I think. So yes, the question number 12 is need to calculate. So question number 12, a vertical rectangular gate 3 meter high and 2 meter wide is submerged in a water such that the top edge is 1 meter below the water surface. Calculate the total hydrostatic force acting on the gate. So this is the question. So you have rectangular gate which have 3 meter height and 2 meter wide. So this is the question. The 3 meter and 2 meter and the 1 meter below the water surface. So this is 1 meter. So all unit in meter. So this is the question. Now you need to calculate the hydrostatic force acting on the gate. So here you need to calculate the hydrostatic force. How much hydrostatic force act on your gate. So how you will calculate? So simple formula, you need to calculate the pressure first, rho gh, then what is your force? So force is what? Pressure is equal to force by area, so you need to multiply with the area. So force is equal to pressure into area. So now how you will calculate? We can see here the solution. So as you can see here the solution, all given things is there. The height 3 meter, width 2 meter, and the depth from the top is below ht is 1 meter, and the density of water you can consider 1000 kg per meter cube, and the gravitational acceleration 9.81 meter per second square. So depth of center of pressure you know already how we will calculate. So because this is a rectangular, so the CG for this block, the for gate will be here, because this is rectangular, so you can consider in the middle. And the center of pressure is what? Center of pressure is your the height from the top and your half of the block. So this will be 3 by 2, so you will get 2.5. Now what is force? So this will be your rho g hcp into a, that is rho g h I was talking about, and a will be what? A will be your height into width, so which is 6. So finally you will get what? The f is equal to 1000, 9.816 into 2.5, so you will get final this value. So 147150. So this will be your correct answer for this question. So question number 12, option A will be correct. So hope you understand what I am talking about. So now, so H means what? H means the middle one. So here is your, this is your 3 by 2 and this is 1. So center from the top it will be 1 plus 3 by 2. So that's why here it is written 1 plus 3 by 2. So now let us move further. Question number 13. A wooden block density 500 kg per meter cube with dimension 2 meter into 1 meter into 0.4 meter is floating in water. Determine the volume of block submerged in water. So here we need to calculate the volume of block submerged in water. You have water surface, and let us suppose the this is the your block which have 2 meter, 1 meter, and thickness is 0 point, this is 0.4. So hope you understand. So now we need to calculate the volume of submerged. So this much, how we will calculate, and density of your block is given, and density of water you know already 1000. So we need to consider these two things. So how we'll proceed? So as per the Archimedes principle, will follow the same thing here. So as you know, the weight of block is what? The weight of block is rho and the volume of block into g. This will be the weight of block. And what will be the buoyant force? Buoyant force is nothing but the rho of water and the submerged volume into z. And as per the Archimedes, or as per the general understanding, so when the body is floating means your buoyant force is equal to weight of the your body, weight of the box. So here you need to put the formula. So Gg will be cancelled out. So rho of wood and the volume of block, and here volume of water you know already, rho of water you know, and volume of submerged you can calculate very easily. So you will get finally volume of submerged 0.4 meter cube. Very simple question, but you need to understand the Archimedes principle. What is the Archimedes principle? And general understanding also you can say. So option D will be correct here. Now let us move on the question number 14. This is 2 marks question. So here in the question number 14, estimate the distance of center of pressure below the free surface for a vertical rectangular plane as shown in the given figure, which is submerged in water with one side of its on the free surface and the vertex downward. The height of the triangular plane is A. So here height is given A, and this is free surface, and the figure is like this. So here you need to calculate the center of pressure. So HCP, center of pressure we need to calculate. So how we will calculate the center of pressure? So center of pressure is nothing but it is the formula for center of pressure is this. So what is the center of pressure? Center of pressure is your center of gravity plus the your moment of inertia, center of gravity corresponding, and sine square theta and A and center of gravity. So here you very easily you can calculate from the top. The center of gravity will be A by 3 and your CP will be here somewhere. So very easily, why it is somewhere below? Because you are adding something here, so definitely it is going to be below. So now for triangular block it is BH cube by 36. So B is B and H is A, so you can put like that. So after the calculation you will get HCP is equal to your A by 2. This is very standard question, so you can expect such type of question in your final exam, NPTEL exam. So option A will be correct here for question number 14. So now let us move on the question number next question. This is your question number 15. Yes, so here question number 15 is there. So question number 15 is, if the 90% volume of an iceberg is immersed in a seawater and only 10% volume is above the water surface, what is the density of iceberg in kg per meter cube? The density of the seawater can be taken as 1025 kg per meter cube. So here the density of sea water is slightly higher than the density of your water, normal water. So as you know here 10 as the value is given. So now, so here we need to calculate the density. Again the same principle here. Let us assume you have the sea like this and the 90% of the iceberg is immersed. Means you have iceberg and the 90% is immersed, means 0.1 of volume is above and 0.9 of the volume is below the water. This is your iceberg. Now the density of sea water is given. So what is the formula? Formula is the volume of or weight of your iceberg, weight of ice is equal to buoyant force, because it is floating, and if it is floating means this concept should be valid. So now what is the weight of your iceberg? So density of ice into your volume of ice plus into z. Similarly, what will be the buoyant force? So buoyant force will be your density of your displaced dis, displaced water, or you can say the sea water. So density of sea water into the volume of submerged or volume of displaced water, which is equal to the volume of submerged. So you can say, you can write like that. And now the final one is g. So g will be cancelled out, and the formula here it is given rho, the value is 0.25, and this is your nothing but this is your 0.9 v, this is submerged one, and rho ice, and this will be your v. So finally what is the volume? So v will be cancelled out. So rho of ice is nothing but it is equal to 0.9 times of, or let me write very clearly here. So ice is 0.9 into 1025, which is nothing but is your the whatever the answer is coming 922.50 kg per meter cube. So this will be your final answer for ice. So hope you understand. So like this you can see here very clearly the solution and question. Okay, so this is the end of this week 2 questions of set 1. So I have lot of sets, so let us move with the next one. So next one is, here you have the hydraulic engineering week 2. So this is also the previous year question. So now let us move on the next one. So the question is, in steady flow of a compressible fluid flow through a pipe, the density, area and velocity of a particular section are 1.5 kg per meter cube, 0.5 meter square. The density is this and the area 0.5 meter per second, 0.5 meter square, and the velocity 3 meter per second respectively. At another section, the density and area are 1.5 kg per meter cube and 1 meter square respectively. What is the velocity at that section? Very simple conservation of mass. So conservation of mass is what? Rho 1 a1 and v1 is equal to rho 1 a2, or rho 2 you can say a2 v2. So here you need to put why it is rho 1 written, because the compressible flow, and so the density steady flow of a compressible fluid flow through the density area and a particular section is 1.5, 0.5. This is the given. So here you can put the value and you will get finally the answer. Very simple question. So now let us move on the next one. So next question is, the total acceleration has the same value as convective acceleration in case of unsteady flow, which is true or false. So definitely will be false, because unsteady means what? The fluid property with respect to time should not be constant. So the acceleration have two terms. Let us write in the x direction, which is your the time component du by dt plus, that is local acceleration, and the another one the convective acceleration, which is u du by dt plus v du by dt, not dt, x dx dy plus w du by dz. So this is your convective one. So this is for unsteady condition. So unsteady condition, your total acceleration not equal to your only the convective acceleration. This is your equal to the local acceleration as well as convective. So this will be false. If the flow is steady, then this term will be 0, because no variation with respect to time. So you will get your acceleration with respect to acceleration, total acceleration in case of steady flow, which is equal to your convective acceleration not. So very simple question. Now let us move on the next one. So next question is, the according to Bernoulli equation, so means here question is which equation is satisfy the Bernoulli one. So z plus p by w plus v square by 2z and z plus p by w minus v square by 2z, and here it is given z minus p by w plus v square by 2z. Only here the plus and minus things are changed, everything is same, all term is same. So as per the Bernoulli's, your all head summation should be constant. So here option A will be correct for this question, very simple one. So now let us move on the next one. Question number 4, the velocity component u is equal to lambda x y cube minus x square y, and v is equal to x y square minus 3 by 4 y to the power 4. Then the value of lambda for possible flow field involved steady incompressible flow is. So here we need to calculate the value of lambda, and the condition is given the steady incompressible flow. So steady incompressible flow condition is what? Your continuity equation should be satisfied. So what is continuity equation? You know already. So this is the continuity equation. Del u by del x, del v by del y, and del w by del z is equal to 0. So now you have to calculate the partial differentiation corresponding to x, y, z, and you need to summation. So here very easily we can calculate. So we have only two, v and w. U and v we have two components, so we'll look only two dimensional component, that is u and v. So what will be your del u by del x? It is nothing but del by del x, and lambda x y cube minus x square y. So once you will differentiate it, you will get what? So lambda and y cube minus, here you will get, if it is x square, so 2xy you will get. Similarly, so for del v by del x, what you will get? So del by del x, and v is your x y square minus 3 by 4 y to the power 4. So here you will get what? So this is also, this is y, del v by del y. So with respect to y you need to calculate. So here you will get 2xy minus 3 by 4 into 4y to the power cube. So Now you need to put the here you need to add the something these two things. So lambda y cube minus 2xy, here you can see lambda y cube minus 2xy plus 2xy minus 4 will be cancelled out, so 3y cube plus, because this is 0 because of the we have the component w component here is 0. So after the calculation you will get very simple calculation, lambda is equal to 3. So very simple one. So now let us move on the next one, question number 5. So the concept of stream function, which is based on the principle of continuity, is applicable to rotational flow only, two-dimensional flow only, three-dimensional flow only, uniform flow only. So the concept of stream function, which is based on the principle of continuity, is applicable to two-dimensional flow only. Remember this. So here detailed solution is also given. Let me just read for you. The stream function defines only for two-dimensional flow, which is steady and incompressible. Properties of stream function: if psi exists, it follow the continuity equation, and the flow may be rotational or irrotational. If psi satisfy the Laplace equation, then the flow is irrotational. So understandable. Only continuity equation if it is follow, it means the flow may be rotational or irrotational, both two things is possible. But if it is follow the Laplace, there is a final condition is only irrotational will be valid. So remember for future. Next question, which method is most commonly used in the fluid mechanics for analysis? The Lagrangian method, Eulerian method, control volume analysis, and none of the mentioned. So which method is most commonly used in fluid mechanics? Because in fluid mechanics generally we solve as a control volume approach, so Eulerian method here will be correct. So remember please, we can Eulerian method we can illustrate like the control volume approach also, so always remember. Question number 7. So next question is, which of the following is correct? The path line of two particles in an one-dimensional flow can never intersect. The path line of two particles in an one-dimensional flow can never intersect if the two particles move along the same direction. The path line of two particles in an one-dimensional flow can intersect only if the two particles move along the same direction. Option D, the path line of two particles in the one dimensional flow can intersect if the two particles move along the different direction. So, little bit long options, so you need to read very carefully. So here option B will be correct. The path line of two particles in an one-dimensional flow can never intersect if the two particles move along the same direction. So question 8. So question 8 is about the for continuity equation given by del vector dot v vector is equal to 0 to be valid, where v vector is the velocity vector. Which one of the following is necessary condition? Whether it is steady, irrotational, inviscid, steady and incompressible. So option D will be correct here. So simple one, so I will not go detail here. Next one, so the path taken by the smoke coming out a chimney in concentric circle represent a path line, streamline, streak line, or the stream tube. So this is your option C, streak line. So the final question, and question number 10, which of the following is correct? There will be no flow across the stream tube, there will be no flow along the stream tube, there will be no flow both across and stream tube and along it, there will be flow both across the stream tube and along it. So option A will be correct here. As you can see here, there will be no flow across the stream tube So now we'll move on the next one. So this is your next week question. So question is, the atmospheric pressure at sea level is what? So whether it is 103 kilonewton per meter square, 10.3 meter of water, 760 mm of mercury, all of these. So definitely all values are same, so all option will be correct. Next question is very interesting, remember please. The height of the water column equivalent to a pressure of 0.2 megapascal is what? So it is nothing but it is your 20 point. How you will calculate actually the height of water column equivalent to pressure? So here you have the pressure 0.2 megapascal, which is nothing but 0.2 into 10 raised to 6 pascal, and this is equal to rho gh. Now it is asking about water column, so you need to put here the water column means water density, and g is, I am going to take g here is as a 10 or simple calculation, and h of the water column. So here 2 into 10 raised to 5 you can write, so 40 will be cancelled out, so only 10 will be remain. So answer will be approx 20, so option B will be correct here for question number 2. So now let us move on the next question. So next question is, the liquid used in manometer should have low density, high density, low surface tension, high surface tension. This is a big question from the designing part. So it should be high, because why? If you are going to measure, let us suppose the high density fluid, and if you are putting the low density, so what will happen? So you need to have the manometer height should be very high, otherwise you cannot measure. So here you can see the detailed solution. The liquid used in manometer should have high density, so that the height of the column can be reduced. Because of the manometer are used for high pressure measurement, so it is important to make a column height in a practical limit. So this is very important. Manometer used for a high pressure. So if you are going to measure high pressure and you are using the not using the heavy density liquid, so what will happen? You need, let us suppose you have mercury option and you have the water option, so you need to choose mercury, because this is the mercury density is what? So this is around, and the water density is 1000 only. This is 13,600 kg per meter cube for mercury. So we'll use this one, and if we'll use this one, so the manometer here you can see that it is important to column height. So manometer column height in this case will be, if for representative point, if this is like that, so in this case that will be 13 times more. So it is like that. Just imagine here. Now let us move on the next one. Very interesting question number 4. A water tank contains 1.5 meter deep water. The pressure exerted by the water per meter length of the tank is 8.29 kilo Newton, 9.28 kilonewton, 11.03 kilonewton, or 12.26 kilonewton. So very interesting. So again, the very simple one, only rho gh into area. So here, so water tank, let us assume here you have water tank like that, and which is deep 1.5 meter, the height is 1.5 meter, which is filled by water. The pressure exerted by the water per meter length of the tank. So per meter length means L is equal to 1 meter is given, and height is already given 1.5 meter. So now what is pressure? What is pressure force actually? Pressure force is nothing but the pressure into area. So what is pressure? Rho g h bar into area. So rho is, as you know, 1000. So here is rho is 1000 and g is 9.81 and h is what? It is nothing but h by 2. So if a is h into l, so rho g and h by 2 l, so what you will get? Rho g h square by 2. So this is written, and rho g is nothing but your omega. This is omega. Omega means unit weight of water. So this thing is only the simplified version of your equation. So 1009.81, 1.5 meter square and 2, this will give it. Finally you will get 11.03 kilonewton. So option C will be correct here for question number 4. Now let us move on the next one. Our next question is question number 5. Very simple one. So the equation of the streamline passing through the origin in a flow field, u is equal to cos alpha, v is equal to sin alpha, for a constant alpha is determined as a y is equal to x cube, b y is equal to x cot square alpha, option C y is equal to x tan alpha, and option D y is equal to alpha sin x. So these options you have. So the equation of streamline is what? Del x by del x by u is equal to del y by v, or you can say like that also, del x by del y is equal to u by v, but the best representation, del x by u is equal to del y by v. So here you can put the formula. So you can put the given value, u is equal to cos alpha and v is equal to sin alpha, so similar thing, and after your integrating both side, so definitely this will be x sin alpha equal to y cos alpha plus c, and at x is equal to 0 and y is equal to 0. So because it is passed through the origin means x and y both is equal to 0, so that's why here it is taken. So c will be 0, and after the calculation, that is just rearrange the term, you will get y is equal to x tan alpha. So very simple one. So option C will be correct here for question number 5, I think. Yes, for question number 5, option C is correct. Very interesting question, you can remember. Next question. So yes, a uniform body 3 meter long, 2 meter wide and 1 meter deep float in water. If the depth of immersion 0.6 meter, then the weight of the body is what? Similar question as we have solved previously. The very simple one, the same principle, Archimedes principle. What Archimedes principle tells, the weight of your floating body is equal to the buoyant force. So weight of your floating body, is equal to your floating weight. So buoyant force. So weight of body is what? Weight of body is nothing but rho, and rho of body your, and the volume of the body into g is equal to what will be the buoyant force? Is nothing but the buoyant force is rho of your water, or if it is in water, yes, it is in water, into your volume of submerged, submerged you can say, or displaced, same thing. So whatever the volume will submerge, the similar volume, the same amount of the volume will be displaced from your container. So you can submerge, or you can write the displaced into g. So g will be cancel out. So here you will get what? If 3 meter long, 2 meter wide and 1 meter deep, so the depth of immersion is 0.6, means if you have body like that, depth of immersion is 0.6, means 0.6 V and 0.4 V. Total is V. So here row of body is you need to calculate. Row of water you can consider 1000. Row of submerged is 0.6 V, and this is complete total V of the body and the row of the body. So row of the body will be nothing but the 0.6 times of 1000. So this is the row of the body. Now we need to calculate the weight of the body. What will be the weight of the body? So if it is rho, so what is weight? Weight is nothing but rho into z. This is your, because what, let me just explain you. So density is equal to what? Mass by volume. So your weight is what? Mg. So this is your rho vz, you can write here. So rho is 600 and v is given 2, 1 and 3. 2 into 1 into 3, and g is, let's suppose I will take 10 here for the calculation purpose. So 2 3 is 6 and 6 6 is 36. So 36 and 3 is 0, so 36 kilonewton you can say. So it is about 36, which is maximum, because less than 36, because we have considered here 10, that should be 9.81. so less than means we cannot go for this, we can go for 35.5 kilonewton per. So option C will be correct here. Very simple one. So same concept you can use here. Now let us move on the next one, question number 7. Question number 7 is, okay, so a two-dimensional flow field is represented by your psi. Phi is equal to 2xy minus x. Determine the value of velocity v at the point 2, 2. So very simple one. So option A is equal to 1, option B 4, option C 4.12 and option D 5. So two-dimensional flow field, the phi is equal to determine the value of velocity at the point. Very simple one. You know the very simple formula. What? The potential function. It is nothing but u is equal to del psi by del x, which is given here, and v is equal to del psi by del y. So very simple. The partial differential, so you can do very easily, and after getting your value u and v, just take the magnitude. So the 5 unit will be the correct answer for question number 7. So option D will be correct here. Now let us move on the next one, question number 8. So question number 8 is, okay, in a steady flow of a compressible fluid. The similar question we have seen already, so will not go much about it. Just simply rho 1 a1 b1, so will not look this one. The similar question we have already solved. The imaginary line draw in a field in such a way that the tangent to any point gives the direction of motion at that point is known as streamline. Remember please, option A will be correct here. Next one, question number 2, question number 10. A streamline is a line. So similar question we have, it is the imaginary line. So the same thing here, which is a tangential to the velocity vector everywhere to the given instant. Now let us move on the next one. The pressure less than the atmospheric pressure is known as suction pressure, vacuum pressure, negative gauge pressure, all of the above. So you can say all of the above. Suction you can say, vacuum say, negative gauge pressure you can say also. Question 12. For a perfect incompressible liquid, which following for a perfect incompressible liquid flowing in a continuous stream, the total energy of a particle remain the same while the particle move from one point to another point. This statement is called what? Total energy should be same. Remember please. So this is energy balance, energy conservation. So this is your Bernoulli equation. So now let us, we have also, I have question. So now let us move on the next one. Very interesting. So next one is the hydraulic engineering, which is from again IIT Kharagpur. So these are the previous question. Maybe you can expect the your assignment like that and final NPTEL exam also. So now question 1 is the compressibility is reciprocal of what? The bulk modulus of elasticity, shear modulus of elasticity, Young modulus of elasticity, and your any of the above. Compressibility. Compressibility your related to bulk modulus of elasticity. So it is reciprocal of bulk modulus of elasticity. Remember. Next question. Find a equivalent head of mercury S is equal to 13.6 for a 10-meter head of water. Means you have water head 10 meter. Means rho GH, rho of water, and H value, H of water you have, means 1000 into G into 10. This much value you have. In terms of pressure I am writing. The 10-meter head of water means the pressure is this much Pascal. Now the equivalent head in terms of mercury, because as you know this is a 13 times heavier than the water, so the value should be less than 10. So how we will calculate? So this is equate just your pressure of water is equal to pressure of Hg. So this is nothing but 1000 into 9.81 into 10 is equal to the S is what? S is the specific gravity. What is the specific gravity? It is the rho of your fluid or liquid divided by rho of standard one. So here the value is given 13.6 and rho of your Hg divided by standard is water, so which is 1000. So rho of Hg is nothing but 13.6 into 1000 kg per meter cube. So here you can write very easily 13.6 into 1000 into 9.81, and you need to calculate H of the height of mercury. So 9.81 cancel out, 1000 will be cancel out. So what will remain only? So height of Hg yes, so height of your mercury is 10 divided by 13.6. So after calculation what you will get, let me just see here, 0.735. so height of Hg is equal to 0.735 meter. So as you can see the how much difference if you are going to design a manometer using water. So for 10 meter manometer height is equivalent to if you are going to use mercury, which is 0.7 meter only. So this is the difference of the using the heavier liquid and the lighter liquid in manometer. So hope you understand. Now let us move on the next one. Question number 3. The paper pulp is an example of pseudoplastic, Newtonian fluid, thixotropic, elastic solid. So question is about paper pulp. So it is your pseudoplastic fluid, remember. So other examples also here it is given. Pseudoplastic fluids are also called the shear thinning fluid. Examples are paint, polymer, solution, blood, paper pulp, syrup, molasses, milk. So these are the pseudoplastic, which is shear thinning fluid. Remember. Question number 4. So water tank contains 3 meter deep water. The pressure exerted by the water per meter height of the tank is what? So similar question, in the previous question it was a 5 meter depth of water. Here it is given the 3 meter. So very simple question. So here you need to calculate the force, pressure force. So pressure force is pressure into area, and here per meter length it is given. So height is given is 3 meter and length is given 1 meter. So area is height into area. Now need to calculate what? Rho g h bar. So h bar is nothing but this is your h by 2 you can say. So h by 2, because it's a rectangular one, here it is not written very clearly. The water tank contains 3 meter deep water, so it should be a rectangular water tank container. Then the question will be complete. Then we can understand whether h bar you will use for circular or rectangular. So here slightly correction is required. So no issue, we'll use the h by 2. So similar question. So I'll not go much detail in this question. Let us move on the next one. So next one is question number 5. Again similar question is the equation of a streamline passing through the origin, again at x and y is equal to 0, and you have u component is cos alpha and v component is sin alpha. So you know the streamline. I am repeating this question because this is very important. So del v by y here, no not y, so sorry, del x by u is equal to del y by v. So once you will put dx by cos alpha is equal to dy by your sin alpha. So once you will integrate, you will get a similar thing, y is equal to tan. So main thing is you need to remember the formula. Now let us move on the next one. Question number 6. A uniform body 6 meter long, 4 meter wide and 2 meter deep float in water. Okay. If the depth of immersion is 0.6, then the depth. Similar question we have solved. So because it is a very important one. So weight of the body, again it is asked. Weight of the body is nothing but the rho of the body and the volume of the body, and let me write here rho of the body into volume of the body into g. So this value you need to calculate. So this will be using equal to the buoyant force. What is buoyant force? The immersed volume. Immersed volume is what? A row of water, let us write first, which is 1000, and immersed volume is nothing but 0.6 times of the your total volume. So 0.6 here you will put. Okay, and now g 9.81, or if you will take 10 here, you can take 10 also, and the volume is given here 6, 4 and 2. So 0.6 v, so v is 6 into 4 into 2. So now when you will multiply, so you will get final answer. If I am taking here 10, let us assume for the calculation purpose. So this is your 6 into 6 into 4 into 2 into 1000. I have multiplied this 0.6 with 10, so this is 6. So this will give you your 48 into 6 into 1000. So 8 and 28. So this will be your okay, and this will be 1000. So I think some calculation error here. So let me just go in deeper. Okay, so here is what. So this should be equal to the then the weight of the body. Weight of the body is, it should be is equal to the buoyant force, and buoyant force is nothing but Fb. Fb is equal to row of the water. I think we are doing somewhere mistake. Let me just see. And the depth of immersion, which is your 0.6 times of the volume, and your the 9.81. So this is your 1000 into 0.6, and volume is given 6 into 4 into 2 into 9.81. So let me just calculate using my mobile, so hope the answer will be correct. So it is 1000 into 0.6 into 6 into 4 into 2 into 9.81. So it is coming around 2825, something different. What is the answer expected here? So let me just see where is the mistake. So how it is solved? The uniform body, the volume is 48 meter cube, and the volume of water displaced, which is equal to the volume of the body, the weight of the body divided by the specific weight of the water. Okay, the specific weight of the water in kilonewton. So weight of the body is, or it is what actually here written. So this is weight of the body, okay, W, divided by the specific weight of the water, means rho g. Rho g, specific weight of the water is nothing but it is rho and g, and the volume. So this will be your specific weight, which is equal to the volume of displace, and volume of displace is nothing but what is. So if I am right from here, so this is the volume displaced, this is the volume displaced, so it is equal to your Fd divided by rho W, rho of water into 9.81. So this is your volume displaced. So rho of water and your G value, and what is this FB? FB is nothing but the weight of the, because the body is floating, means the weight of body is equal to FB. So FB you can write very clearly here, the weight of the body. So here it is weight of the body, and the volume displaced is rho and 9.81, and which is in kilonewton, so that's why it is written 9.81 only. So V is equal to, because it is, if this is in kilonewton, if you are going to write this is in kilonewton, so that should be is equal to which is your only 9.81, because this row of water which is 1000, that will be converted in Newton to kilonewton. But here I think why it is written 9.81, let me just understand the thing. So I think this is wrong, I think the question 1, equation 1. Why? Because if you will write here the kilonewton divided by kilonewton per meter cube, so finally we will get the meter cube, no issue, the volume of displaced you will get. But what, so why this value is 9.81? Because if you are going to write the specific weight, okay, this is something called a specific weight. Okay, let me just solve in the different way. So I think this is correct, because it is not weight only, it is telling the specific weight. So weight divided by volume, so volume will be cancelled out. Here it is means the weight divided by volume, so whatever you will write the volume here, volume will be cancelled out. So this is correct, I think. But it should be, answer should come if we are solving like that also, because it is a very simple way. Where is the mistake? So something is miss. I'm doing mistake here, I think, in this question. So let me see in different way. So here is FB. FB is equal to or weight of the body, rho of the body into volume of the body into G is equal to your the buoyant force, which is the rho of water into volume submerged into G. So G will be cancelled out here from, and the volume of body, the density of the body is, we need to calculate, and this is, let us suppose this is given V, and rho of water is 1000, and the volume is rho of body, and the volume here 0.6 V. Why 0.6 V? Because 0.6 times only 0.6 the depth of immersion is 0.6 meter. Okay, depth of immersion is 0.6 meter. Okay, here is the little bit twist in the question. So here depth of immersion is 0.6 meter, remember please. Not the volume 0.6 times immersion. So this was the confusion here. So now I got it. Okay, so I think we need to solve in the different way, not different way, the similar way. Let me just, I'll show you in the very clear way. So here the question is depth of immersion 0.6 meter, not 0.6 times of the volume. So this is the big problem here. Let me just erase. So you need to read the question very carefully, please. So means you have the water body, and within the 0.6 meter long and 0.4 meter wide and 2 meter deep, means it is like that. If the depth of immersion is 0.6 meter, means 0.6 meter only, remember please, and this is your rest of the volume. This is 1.4 because total is 2 meter. Now your weight of the body is what? Weight of the body is nothing but FB, and FB is what? The row of water 1000 into the depth of immersion, the volume of the immersion. Volume of the immersion is what? 0.6, height and wide is 4 meter and long is 6 meter, into G, 9.81. So now you can calculate, you will get the answer. So 1000 into 0.6 into 4 into 6 into 9.81, which is equal to 141,264 kilonewton. Newton, not kilonewton. So in kilonewton, the answer will be your 141.264 kilonewton. So very simple one, but here you need to understand the question. The reading of questions should be very carefully, because I read the question in not proper way, so that's why there was a mistake for solving the question. So remember please. So this is the immersion is 0.6 meter, not the 0.6 times of the volume. The similar question I have seen. Let me just see where we have solved. I think that place also I have did mistake. So let me just clarify. Yes, here is the similar mistake I have did. So here you can also correct the same thing. 0 point, if the depth, here you can see the 0.6 meter immersion and the 1 meter deep. So this will be 0.4 and this will be 0.6. So weight of the body is what? FB. Very simple. 1000 into your 0.6 into 2 meter wide and 3 meter long into 9.81. So when you will calculate, you will get the answer. So hope you understand the things. 1000 into 6 into 2 into 3 into 9.81. So this will be your 353,160 Newton. So in kilonewton, that will be your this is 0.6. So this will be not there. So Newton. So when we will calculate in kilonewton, so 35.37 kilonewton. So 35.37. So hope you understand. So this previous one was wrong. So remember please, read the question is very careful, then you try to solve the question. Now we have another questions also. I think let me just go very quick, because we have, okay, this question we have already solved. We have already seen the two-dimensional flow field represents psi is equal to 2xy minus x. Determine the velocity. So similar, you know already u and v, and just take the root over both component. Similar question we have seen the rho 1 a1 b1, the streak line and the streamline is a similar question. Here a depth of center of pressure for a triangular lamina H and the base B immersed vertically in the water and with its base of the free surface. So here what will be their center of the depth of the center of pressure. The similar question we have seen already. So it will be your HC Ig divided by AH. So what will be the HC? Because why I am telling, here we have seen the question. I think here. Mm, yes, here we have seen the question. So hope you understand. So but here in the previous question was A, here is H, nothing change. So question 11, and here the Bernoulli, the change of, let me just read the question. For a perfect incompressible liquid flowing in a continuous stream, the total energy of a particle remain the same while the particle move from one point to another. This statement is called the Bernoulli equation. So now I am going to end the session, which is already I have recorded 1 hour, more than 1 hour, 1.5, 1 hour 5 minute. So thank you for understanding. If you have any question, you can discuss in the next class. So thank you.